Good evening, everybody. Today I'm going to discuss inverters. So, in this lecture, inverters. So, I will cover what is the basic block diagram of inverter and what are the switches we have to use, what are the applications of inverters, and all those things one by one we can see. So, traditionally, we already have this AC voltage and AC current, right, generating by the synchronous machines from the power stations. So, but what is the necessity of inverters? See, and in the earlier days, we can get the AC voltage and AC power or AC current, whatever it is. So, from the synchronous machines from the power plants. So now, after installation of this renewable energy sources, solar power or whatever it may be, fuel cells, right? So and wind, etc. We can generate the power, right, by using that renewable energy sources also. But solar will gives DC voltage, wind AC voltage, and fuel cell will give DC voltage. So definitely a power conversion is required. So to run AC loads. So for that conversion, we are using this inverter. So now this devices used to convert DC to AC are called as inverter. So this is the block diagram of the inverter. So here, if you observe, this is the DC voltage source and this is the AC. This voltage may be single phase or polyphase, whether it may be three phase. Generally, we'll go for the three phase for as far as this syllabus is concerned. And so now we are seeing here this DC is converting to AC. Here we are using one circuit. That circuit we can call it as inverters. So in this inside what happens is some power semiconductor devices we will use. We'll discuss later which device will be more flexible for the inverter nowadays. And coming to here, if you observe the first sentence, inverters are used to convert the DC input into a sinusoidal AC output, variable frequency and amplitude. This is the most important thing, variable frequency and amplitude. So generally our AC loads are 50 Hz frequencies, right? And we can change the output voltages as well as output currents also. So let us say one example, variable frequency, where we will use this variable frequency. Just I will give one example. Later we will discuss clearly when we will see. We are going to see the application. Then I will clearly explain. Variable frequency. Then we already know the speed control of induction motor by using V by F control. So in that V by F control, generally we require variable voltage as well as variable frequency to keep the torque as a constant. So for that we require this variable frequency and amplitude that we can achieve by using this inverter also. So this is the block diagram of inverter which converts this DC to AC. And see, this is a just again I'm explaining. So this is a DC, pure DC signal, and this is the AC signal. This signal, that means AC voltage, this AC voltage that may be 50 Hz frequency or 60 Hz frequency or 70 Hz, whatever may be the frequency. And from this we can achieve the variable frequency as well as amplitude. Amplitude also we can change because just now I have discussed that for V wave control of induction motor, to keep your torque as a constant, if you vary the frequency, right, you should also vary the voltage, then only you can maintain the torque as a constant. Of course, we'll discuss it later clearly. Just I want to show this one. And next, here the sources of inverter. What are the sources of inverter? So the main source of electrical power is the battery, which is a DC source. So next one, the DC output of the battery is bucked or boosted according to the requirement and then converted into the AC using DC to AC inverter. So what is this buck and boost means? So for example, if we are using the DC battery voltage or solar panel system, for example, if we are getting excess voltage, then we have to step down that voltage. That is nothing but a buck operation. For example, if you are getting a low voltage, then we have to use boost operation. So to meet the proper requirement of the load. So here the next two sentences are very important. So the function of inverter is to change DC input voltage to symmetric AC output voltage of desired magnitude and frequency. So along with that, one disadvantage, major disadvantage which we are facing in inverters, the output voltage waveforms of ideal inverters should be sinusoidal, but practical cases, what happens is, however, the waveforms of practical inverters are non-sinusoidal and contain certain harmonics. So probably the harmonics are odd harmonics, that is 3, 5, 7, 9, like that, and so on. So here, again I'm saying that the major disadvantage of the inverters here, it will inject some harmonics because we are using a power electronic devices. Definitely a harmonics will be injected into the system. So that harmonics we have to reduce by using some techniques discussed later. So here in the sources of inverter, it may be battery or DC source or fuel cell we can use or solar panel. So we'll see that. So now see, this is a solar panel and we can store the energy in this battery. So this is the sources we can use. And coming to this applications, where we are using this applications. So generally in our daily lives, in our homes or in our college units, a microprocessor lab, we have UPS system. So therefore, in this uninterruptible power supply UPS, this is nothing but UPS. So in that, from this UPS, you can supply to variable loads. Sorry, not variable, different loads. What are the different loads are? Well, here I am showing this is air conditioner, pump or motor. Pump is nothing but motor, you can see. And it's a washer and a large ice cube and air compressor, right, like that. But who is giving the power here? You can see here solar panel and battery. So these two are very important nowadays. So this is one daily life you can see. And next, coming to adjustable speed drives. So this is our speed drives. So now see, this is the grid, and after that we are converting from AC to DC. So rectifiers in the second unit already we have discussed single phase as well as three phase system. And after rectifier we will get some pulsating DC. To get a pure DC we are using this capacitor, which is nothing but DC bus voltage. And because inverter it requires DC, so we are using this capacitor to get pure DC. Again, this DC is converting into AC, so which is nothing but three-phase induction motor. So if you observe clearly here, I have written it is converting from AC to DC, again from DC to AC, and here motor will be running. Now, if you observe this waveform and this waveform, both are very important. From the grid, assume that almost nearly pure sinusoidal waveform you are getting. But here, what happens? See, it's not a pure sinusoidal. It consisting of some harmonics. So we have to reduce that harmonics before we are giving to the induction motor. Otherwise, the motor windings get heated up. That is a problem. So this is one application. So rectifiers and inverters are very important thing, which already covered in the rectifiers in second unit, single phase and three phase system. And one more is electronic frequency changes circuits used in induction heating and welding, etc. So this is the welding, inside that also we can use it. And here, so this one, still some more applications are there. I am not going into in detail. So first one is very important, HVDC transmission system at low power levels. And renewable energy such as solar, fuel cell and fuel cell to AC conversion. Electronic ballast and compact fluorescent lamps, active filters for power quality improvement, and this custom power devices, DStatCom, DVR, UPQC, and StatCom SC, UPFC. This will be, you will get these things in your next semester to take the subject of HVDC and facts. Okay, now we'll see the first one is very important, HVDC transmission at lower power levels. Here, what happens is generally the generator, what happens, it will generate AC only. Thereafter, here we are using rectifier. it converts AC to DC. After that, we are using one big capacitor, so it will give constant voltage DC, and we are transmission DC transmission. So here in the DC transmission system, a lot of advantages are there that will be covered in the next semester. One thing I want to tell you is in the DC transmission system, for example, in the DC means what happens is reactance is zero. If you take AC system, AC transmission lines, so resistance and reactance both will be presented, but here reactance will be absent because of the frequency is zero. So that is the advantage. Therefore, losses will be less, but some initial costs will be increases because we are using some here AC to DC converter, some protective equipments, all those things. So, but losses will be reduces, and again at the receiving end, again we have to convert DC to AC only because 90% of the loads in our home appliances are AC. Of course, some DC loads are there like laptop and mobile charger, etc. Whatever. So, but AC loads are increased. AC loads are more. That is nothing but refrigerator, air conditioner system, fans, whatever it may be. So again, we have to use here inverter. So here we are focusing generally in this unit on mainly on this one. So DC to AC inverter. This is very important. Here after that we are going to the network. So and this will be covered detailedly. So next slide. So now practical block diagrams of inverters. Generally, how it will be there? How it will be these block diagrams? So let us say this is the first one and this is the second one. So I said that generally nowadays the sources are solar panels, fuel cells, and battery storage system and wind energy. Okay. Now here I am not showing any wind energy conversion system, but I am showing this PV panels and fuel cell. The same fuel cell you can also see this is the fuel cell stack. So now, what is the main difference between these two? This is a hydrogen-based fuel cell generally we are using, but the cost is very high. Even if you want to generate some 10 to 15 volts also, so compared to the solar panel. So that's why generally everybody will use solar panels or some small wind energy, which is called as aerogenerators. Firstly, we have to convert AC to DC. Again, we have to convert DC to AC to control the load. So because directly wind energy, wind will generate AC, that directly we cannot connect to the load. So instead of that one, we can use first wind, after wind energy, we are using AC to DC, again DC to AC, like that. So if you observe here the PV panels and fuel cell, and here we are using DC to DC boost converter, which is nothing but step up chopper, which already covered in the last unit. Step up chopper or boost converter. The small difference is that just we are using some filter for the step up chopper, then we can call it as a boost converter. So after this boost one, let us say here 25 volts it is generating. By using this boost converter, I can generate here 50 volts. That 50 volts I can give it to the inverter. This is the inverter, 4 switches. After this inverter, you will get AC, and it's not pure AC. That's why we are using a filter, and that is connected to the loads, AC loads. So this is for closed loop control system, active power, reactive power, right? This is the thing. And this is another one. So generally for the traction system, this is for traction system. If you observe, these two are the wheels, right? The motor. So here we are using hydrogen fuel stack, and here battery storage system, right? So now this fuel cell is given to the boost converter. This boost converter is given to this battery for storage, or sometimes directly can give to the inverter, or directly given to this fuel cell also. So this from this battery you can give, or from this boost converter also directly you can give to this one. So that is depends on the situation. So for here in this case, what they are using is fuel stack and boost converter. First, they will store the energy into the battery. After that, this battery is giving to the power to the inverter. That inverter will drive the three-phase induction motor, and these two are the wheels. So this is generally inverter will do some work, right? So that means conversion from DC to AC. Generally, I am saying, but nobody will use nowadays DC voltage source directly. Everybody will using this energy storage system, battery energy storage system, or solar panels, or fuel stacks, fuel cell stacks like that, etc. Or some people will use wind also. But what happens is, if you use wind, it will produce as AC, that we have to convert into the DC, again from DC to AC. So directly, because inverter requires DC, so directly wind energy it will produce as AC, that AC we cannot give to the inverter, so some conversion is required. So that's why again we are using AC to DC rectifier. So this is about practical block diagrams of the inverter. And next very important thing in the inverters, what are the switches we have to use in inverters? So this is a thyristor, so very popular device having highest voltage rating and the current rating also, but the frequency is 50 to 60 Hz. So this is the major drawback in the inverter. And also, if you use this thyristor, one more drawback is that because the thyristor requires forced competition in the inverter, because what is the supply is DC supply. If you give the DC supply, always your ACR will be on. You cannot, it won't be turned off. So to turn off this again, what we require is forced competition. So that's why we are not going for this one generally in the inverters. So except for high power rating. For high power ratings, when you are going for high power HVDC transmission systems or fax devices, then obviously we have to use this thyristors. But nowadays IGBT is also more popular. We'll discuss one by one. And this GTO gate turn off SCR. So this is 6 kilovolts, 6 amperes, 1 kilohertz switching frequency, 1 kilohertz. So now gate turn off SCR means you need not require forced competition, but gate voltage must be reversed to turn off this. And now see, this is IGBT MOSFET and this MOSFET SIC. Nowadays, silicon carbide MOSFETs are more popular. Silicon carbide IGBTs are also more popular. So now see this IGBT, 6.5 kilovolts, 3 kiloamps, and 100 kilohertz. So now here IGBT compared to the thyristor, what is the main important thing is thyristor requires forced competition. IGBTs need not require any forced competition. Just if you remove the gate pulse, it will be turned. That is the important point we can consider in IGBT. See the rating, this is 7 to 10 kilovolts and this is 6.5 kilovolts. So now, and the frequency is 100 kilohertz we can use. This is a switching frequency, it's not a supply frequency. Switching frequency is nothing but the switch you can on and off that frequency, I'm saying. And coming to the MOSFET, that is less voltage. See, this is kilovolts, this is volts. So whenever you require a medium power ratings, then you can go for this MOSFETs, less current rating, but frequency, when you are going for high switching frequency, so then we do. And see, if the switching frequency is increases, what happens is, so now see, here we are using this filter. The filter is nothing but generally LNC. If this switching frequencies increases, right, the size of this LNC components are decreases. So if you see the transformers generally or inductors, manufacturing books, any books if you refer, that frequency is always inversely proportional to the size of the equipment. So if this frequency is increases, the size is reduced. What is this frequency? Switching frequency. It's not a supply frequency. Supply frequency is different, switching frequency. So based on this, I conclude that this IGBT is more dominating one compared to all other devices, because the thyristors require forced competition, even though it will having a capability of 7 to 10 kilovolts. But it requires forced competition. But IGBT need not require any forced competition. Just if you remove the pulse, it will be done. So now, this is a picture of IGBT, the semicron based one. Now see, this is the symbol of your IGBTs. So now in one leg, two switches are there. In one leg, two switches are there. This is the IGBT, and inside, see this plate I have represented here. This is semiconductor, so like P-type, N-type, whatever it is there. This is a silicon gel for insulation purpose, and the substrate, N-type substrate or P-type substrate, whatever. So see, observe this leg having two switches. This two switches you can observe, see here. Whatever this one leg is there, this one leg is this. So if you purchase this one IGBT semicron based, then what happens is in one IGBT. I mean, in one total one semiconductor switch, you have two IGBTs. So depends upon your current rating, your cost will be increases. So this is the thing. And so classification of inverters. This uh, will be discussed in the next class.